Hello, everyone. This is Joe and Ann from MecSoft Corporation. Thank you for taking your time to join our webinar, What's New in VisualCAM 2019 for SOLIDWORKS. I'm the product manager here at MecSoft for this product, and I'll be joined today by Uday Honalagare, who's our support manager, who will be actually doing the demo. So a little bit housekeeping tips before we get started. The recording of this webinar will be made available in a couple of days. We'll clean it up, get the recording, clean it up, and then we'll make it available to all the registrants. As well as we will be reserving 10 minutes of the webinar at the end for questions, but also we want to make it interactive, so you can use the chat window for actually adding your asking your questions, and we'll try to answer them as the webinar progresses. We can either answer them by text, or we will stop the demo and try to give you a quick detour to answer that question. And then the agenda for today, the topics would be the VisualCAM. Initially, we'll be talking about the VisualCAM configuration changes. There's some exciting configuration changes in the new product, and they'll be talking about that. We'll talk a little bit about the usability enhancements that have gone into the product. And then more importantly, and probably the most important things that people are looking for, is the machining methods enhancements. We have enhanced quite a few of these machining methods. And then also simulation, cut material simulation enhancements. And then finally, some of the post-processor enhancements. So without any further ado, I'll let Uday take it away. Uday?
Thank you, Joe. Hello, everyone. Good morning, good afternoon, or good evening to you all, folks. And thank you for joining us today for our webinar on VisualCAM 2019 for SOLIDWORKS. So we will be covering the new features that have been introduced in VisualCAM 2019 for SOLIDWORKS. And for those of you who aren't familiar with VisualCAM 2019 for SOLIDWORKS, VisualCAM is a gold-certified CAM product that completely runs inside of SOLIDWORKS. It runs in versions 2011 through SOLIDWORKS 2019. So you can run VisualCAM 2019 in any of these versions of SOLIDWORKS between 2011 through 2019. And it's a gold-certified CAM partner product. Now, we will be covering all of the new features that have been introduced in VisualCAM 2019 for SOLIDWORKS. So without any further delay here, I will go into the What's New document to kind of briefly go over the new features that we will be introducing. And I will also be demonstrating these features in VisualCAM for SOLIDWORKS. So we will be making this document available to all our attendees, and also be available on our website under the product page for VisualCAM for SOLIDWORKS. There's been some exciting new features that have been introduced in VisualCAM for SOLIDWORKS. So one of the brand new feature we've introduced is a new module. It's called the Millturn Module that has been introduced in VisualCAM 2019 for SOLIDWORKS, and this is currently introduced as a beta release with the 2019 product. And I will be giving a quick demonstration of our Millturn module here shortly.
While Uday is getting ready, I just wanted to also mention that we will be releasing the product actually shortly, in probably later part of this week or early part of next week. And so please look out for the emails announcing the release of the product.
Okay, folks, for those of you who are already familiar with our VisualCAM product, as you know, it runs inside of SOLIDWORKS, and VisualCAM Browser will be visible to you right next to your Feature Manager design tree, just a single click of the tab. And you'll also see the VisualCAM interface appearing in your Command Manager as a tab right in here. Now with version 2019, you'll see that there's a new browser window for Millturn. So you can toggle between Mill and Turn. You can go directly into Millturn as well. So selecting Millturn Browser will display the interface, the machining browser interface for the Millturn module in here. So we have the turn programming operations here for the turning as part of the Millturn. you have the tab for milling operations. So you can program both milling and turning operations from the Millturn module. So you have the 2-axis turning operations for turn roughing, finishing, groove finishing, follow curve, threading, and parting off. And you do have the hole machining, which can be programmed actually along the axis of rotation. And under the Program Mill tab, you could program 2, 3, 4-axis and hole machining operations in the Millturn module. So the interface for the machining operations, the browser look and feel looks very similar to what you noticed in our milling and turning modules. So in this particular example, what I'm demonstrating here, you'll notice that there are some features that require milling operations in addition to turning. So I've already programmed a couple of turning operations in here, a turn, roughing, and a finishing. So I'll switch over to the view so we can simulate the turning operations. So I'm going to go into the Simulate tab and run a simulation for the turn roughing operation and the turn finishing operation. Now, once the turning operations have been programmed, I'm going to switch over to the Program Mill tab in here to add a few milling operations. So we can reorient the coordinate system setup, as I've already done in here, and then establish the work 0 over to the front face of the part. In the next step, we could start programming milling operations. It could be a combination of 2, 3-axis, 4-axis, and even hole machining. So I'm starting out with a profiling operation in here to clear out that step. And now I'll go ahead and program a few additional operations. So we'll program this open pocket using a milling operation. So we'll use the 2-axis facing operation to do that. So we'll go into 2-axis facing, and then we'll pick the face edges in here. And then we'll make a selection for the tool. We set the feeds and speeds clearance, very similar to how you've been used to programming in our other modules. Cut levels, and then generate gets you the toolpath. So there's our facing operation to program an open pocket. We'll run a simulation for that. And then finally, I'm going to introduce a drilling operation to machine this hole by going to hole machining, drill, select the hole feature, specify the tool for drilling, and then I can set the depth and generate. I'll finally run a simulation for that. So this module is currently available in beta, the Millturn module. And you can give us your feedback, test the product out, and if you need any help, you're welcome to reach out to us. So this is the introduction of Millturn module in VisualCAM 2019 for SOLIDWORKS. Next, I would like to introduce some of the new exciting features. There have been several enhancements in VisualCAM 2019. One of the key enhancements I would like to point out here is we've introduced a newer licensing system in 2019 over our previous versions. So this new licensing system will eliminate some of the issues our customers had noticed during license transfers and release due to some latencies on their end. So these issues have been addressed and have been tested and been run by several of our users in our desktop standalone Visual CAD/CAM product and also Rhino CAM products. And we haven't run into any issues. And this brand new licensing new system eliminates some of those latent issues that users may have experienced with license release and transfer. So 2019 uses a brand new licensing system from Millturn. And as far as the user interface goes, there's not much of a difference for an end user to activate and release a license. The process of license activation and releasing is going to be exactly the same. The changes that have gone in is in the back end, how the activation and release happens. Now, we've also added the newer simulation libraries from MachineWorks, which has been incorporated to all our modules, which has improved performance in terms of simulation, multi-threading, and also fixes some of the simulation issues. Now, as part of the configuration changes, we are now including the turning module in our VisualCAM mill products with standard and higher configuration. So if you have standard, expert, pro, or premium, you will automatically get access to the turn module, and the turn module can be located by accessing the turning browser. So the turn module will be included with mill standard and higher configuration. So for customers who are our active maintenance subscription, who has standard configuration and higher, will automatically get the turn module starting with version 2019. Now, the next thing I'm going to cover is the usability enhancements in VisualCAM 2019 for SOLIDWORKS. And I'm going to go ahead and bring in an example here to cover this. Again, folks, if you do have any questions during this webinar, please feel free to post those questions in the questions panel, and we'll try to get those questions answered to you. Okay, so what I have here is a prismatic part, which has features like pockets, slots and hole features and chamfer features. And I would like to give you a quick example of how we can take advantage of some of the usability enhancements. The first thing I'm going to talk about is the cut depth. So the cut depth can be now defined in the tool in VisualCAM 2019 for SOLIDWORKS. I'm going to go into the Tools tab, and I'm going to edit one of my tools. And you'll notice that under the Feeds and Speeds tab in your tool definition, there's a new parameter called cut depth. So you can specify the maximum depth per cut that you'd like to apply for this particular tool when you're programming any operations that involve in 2.5 axis or even 3 axis like Z-level roughing or horizontal roughing operations. So once this parameter is defined in here, so I have it set for both of these tools, as you see it. And when you go into your machining operation, and as you go over to your cut levels tab, you'll now see this option to automatically pull in the cut depth or depth per cut from the tool. So as you select it, it automatically loads the cut depth or your depth per cut into the operation, and then selecting generate will create your multiple Z levels in the operation that you've chosen. So in the profiling operation, I'm going to go to edit the operation, go into the cut levels tab, and apply the cut depth based off the tool. Selecting generate will generate your toolpath with the depth per cut that you put in. So this feature is available in all of our configurations of the mill module with 2019. The next thing we'll take a look at is tool number conflicts. This is one of the other usability enhancements that's been added to 2019. So this is a very useful tool which allows you to check for tool number conflicts. So when you post-process your set of machining operations, either you post-process a setup or your entire machining job, if you have 2 or more tools that have been programmed with the same tool number, it'll automatically flag a tool number conflict in here, so before you post it. So you can either proceed with post-processing it or select no, go back and take a look at the tools that have conflict with the tool numbers. As you can see here in this particular example, we have both the tools assigned as tool number 1, so you can go back and edit your tool and change the tool numbers accordingly and then repost it. So this is also a enhancement that's available in all of our configurations of the mill module in 2019. In addition to that, we've also added support for high resolution monitors for 4K displays, so the icons are automatically scaled up. And there's numerous other enhancements that have been added for usability enhancements in here, as you can see in the list. One of the other enhancements I would also like to point out is the setup information will now be displayed in the toolpath viewer. So as you go into the toolpath editor or the toolpath viewer, and when you select the setup, it'll automatically determine and display the setup rotation. So if you had a 4-axis operation in here, and let's say we want to change the machine tool definition from 3 to 4 axis, and you add a new rotate table setup, and specify a table rotation angle. I'm going to put in 180. Click OK. You'll now notice that the table rotation information in here will automatically show up in the setup in here. It shows the rotation angle. So this is a new feature that has been introduced in VisualCAM 2019. So either you have a indexed operation, which could be a 3+2 operation, the rotation type and the setup information will automatically show up under the toolpath viewer or toolpath editor in version 2019. So the next thing I would like to focus on is the enhancements to feature-based machining in VisualCAM 2019 for SOLIDWORKS. And to demonstrate this, I will use the same example that we were covering in here, and we'll go over the steps and how we can generate, do feature detection and generate toolpaths using the features that we've detected. And again, folks, if you do have any questions, you're welcome to post these questions in the questions panel. Now, one of the changes that has gone into the features tab itself is if you go into the CAM preferences and select features, you now have the ability to display the features tab either in the machining objects browser, or you can have it display in the machining operations browser, and you can toggle this behavior by going into CAM preferences and features. And as you toggle it, you will now notice that the features tab appears in the machining browser just right next to your program tab. Now, you might be wondering, why do we need to toggle the features tab back and forth? Now, if you're going to be primarily doing a lot of feature-based machining, it makes sense for your workflow to first have the features tab. You identify the features, you detect the features, and then you can program toolpaths based on the features that you've identified in here. So rather than having the features tab under the machining objects browser, you can have it, the features tab placed in the machining objects browser, so it makes your programming workflow a lot easier when you're working with feature-based machining. So you have the ability to toggle the features tab between the machining browser and the machining objects browser, and this option can be found under CAM preferences, features, and you can toggle it right in here. Now, with version 2019, we've also introduced a brand new feature type, which is called a silhouette feature. The silhouette feature allows you to generate a profiling operation or even a 2-axis roughing operation with a silhouette feature. Now, for those of you who aren't familiar with our feature-based machining, we can detect different types of features for prismatic parts, and we have a list of different features that we can detect. Identify hole features, pocket features, prismatic pocket features, open prismatic pockets, boss features, general 3-axis pocket features. If you have a part which has cavity with a sculpted bottom, we can identify slots, open slots, T-slot features, V-slot, and open pockets which has sculpted bottoms, and planar face. You can identify fillets, chamfers, step pockets, and with 2019, we have the brand new silhouette feature. So the list just keeps expanding and growing, and a silhouette feature is a great way to program profiling or 2-axis roughing operations in here. Now, one
quick note on the features, you don't really need to have an intelligent solid. You can have a dumb solid. You can have imported solid into SOLIDWORKS, and we will be able to identify these features. So we're looking purely at the geometry for determining these features and not the SOLIDWORKS database. Thanks, Uday.
Thank you, Joe. So as you can tell here, the features that are identified have been automatically listed under the features tab. So we have the silhouette features, and as you select each of these features, the corresponding features are highlighted on top of the part geometry. So we have hole features. There's 4 holes of the same type, so they're all grouped automatically. And then you have the chamfers and the 2 prismatic slots. And if you're running configurations like Expert, Pro, or Premium, you'll also be able to identify features in multiple different orientations, like one for the top, one for the bottom. If you have features on the sides, each of those can be identified. So what we just did was a automatic feature detection. So it automatically identifies all of the features based on a given orientation for the part. Now, once we have these features detected, we would like to go ahead and program toolpaths with just a single click of a button here. You can select automatic feature machining, and the toolpaths were generated. So I'm going to switch from the features tab over to the program tab, and you will notice that the operations have been generated, the depths, everything has been derived based off the features. And if you'd like to make any changes in here, for example, you want to swap out a tool, you can just select the tool from the Tools tab and drag and drop it on top of the operation. Or if you want to make an edit to change the parameter, like you want to change your cut pattern or your step overs, you can always edit the operation and make changes to it and then generate the toolpath again on it. So once you have your machining operations generated for each of these features, you can go over to the Simulate tab and perform a simulation in here. So we'll do a cut material simulation. So we'll select the operation and select play, and that runs the cut material simulation. And you can apply colors for each operation are based on the tool. So you can see the, during simulation, you can see the material removal process along with the colors being specified for each and every operation. So with just a few button clicks here, you're able to detect features and generate toolpaths using feature-based detection and feature-based machining. And this is available right from our standard configurations. So standard, expert, pro, and premium configurations include feature detection and feature machining. And again, folks, if you do have any questions, please feel free to post those questions in the questions panel, and we'll do our best to answer them for you. Okay, so next we'll cover some of the other enhancements that we have introduced in version 2019. So I'm going to talk about a brand new method, a toolpath method that's been introduced. It's called a knife cutting. And this is available, again, starting right from our standard configuration. This is a great way to program using drag knife. If you want to cut like materials that are not too thick, like thin materials like veneers or sheet metal, so you can cut it using drag knife operations in here. And I'm going to use an example to demonstrate this in VisualCAM for SOLIDWORKS. Again, the examples I'm using here are just for illustration purposes. You could be working off your own part files or more complex examples here. This is just to demonstrate how easy it is to program these operations using VisualCAM for SOLIDWORKS. Now, the drag knife operation can be found under the two-axis methods. And you'll see a new operation type called drag knife. And again, this is available right from our standard configuration. You would be able to also define your tool under the Create Edit Tools tab. And you can specify the blade width, length, blade, the offset, all the parameters to define your drag knife. And as you program your machining operation in here, you'll be able to define the total depth and the swivel depth for your drag knife operation in addition to the corner limit angle. So once the toolpath has been generated, you'll see the cornering actions being applied in here. And we'll run a simulation so you can see how the tool automatically tilts and to maintain the cut. So I'm going to go back and rerun the simulation so it makes it easier to view it. So the swivel actions are being applied at the corners right there as it changes direction. Again, this feature is available right from our standard configuration of VisualCAM for SOLIDWORKS Mill module. Again, folks, if you do have any questions, please feel free to post those questions in the questions panel. The next thing we would like to focus on here is the addition of cornering options that have been introduced in two-axis profiling operations. Now, this is one of the enhancements that we've been, a lot of our users have asked for in the past, and we have this available in VisualCAM 2019 for SOLIDWORKS. These are called cornering options in profiling. And again, I'm going to bring in an example to demonstrate this in VisualCAM 2019 for SOLIDWORKS. So the cornering options can be found in 2-axis and profiling. And you'll notice that there's going to be a new tab for cornering parameters. So the cornering options can be set for external corner types and internal corner types as well. By default, round is what we set for external corners and sharp is for internal corners, but you can choose the cornering type that you like to apply for external and internal corners. So in the first example over here, I'm going to use a cornering option for loop for external corners. So as you notice here, it creates a loop around each of those external corners, and you can specify the loop radius in the cornering parameters tab. The next one I would like to demonstrate is the sharp corners in here on this example. So we have selected sharp, and you will notice that in the cutting parameters and the cornering parameters, there's 2 types. One is sharp and you have sharp limited. So sharp limited restricts the overshoot length. So in this particular example, you will notice that by using sharp limited, not all of the corners are sharp because we've set an overshoot length of 0.1. So if you want to set the overshoot length to a larger value, in this particular case, I'm going to change it from 0.4 to 2, you'll notice that it has to overshoot by an extended amount to create a sharp corner. So you have the ability to limit the overshoot length for sharp corners. Now let's take a look at about the internal corners in here. There's 2 options available in addition to the default sharp corners. So you can either use a dog bone or a T-bone option in here. So in this first example, I'm going to use a T-bone as the cornering option. As you can see, it'll extend past the corner, so it'll overcut it in here using the dog bone option. And then the next example over to the right, we are setting it to a T-bone as it extends past to cut the corners out. Now let's go ahead and run a simulation for each of these operations. I'm going to go over to the Simulate tab, select the setup, and then hit play to run the simulation. You can see the cornering actions being applied.
These cornering options were put in for a variety of reasons. Most of it, some of the sharp corner options, T-bone and dog bone, they are more for the woodworking joinery industries, where you have 2 pieces that needed to be joined, and the male port or the female portion has to be cleared completely so the male portion can sit inside. And then some of the looping functions can be used in flame cutting and any of the other laser cutting and things of that sort. So these could be applied in a variety of industries, and that these requirements came to us from a bunch of our customers using it in all of these various industries. So just for your information. And also one of the things I also want to point out is these files that Uday's got, they are all obviously made up files. Just for illustration purposes to show you how these corners actually work. Thanks, Uday.
Thank you, Joe. Okay, folks, the next thing I would like to cover under one of the other enhancements is being able to perform clustering in 2-axis operations. So clustering is useful when you have inside and outside that needs to be cut out on a profile. So for example, you could have again, this is an illustration of a part. What I'm showing here is we have profiles that needs to be cut on the inside as well as the outside in here. So typically when you program it, it profiles in the order in which you have selected the part regions. So in this particular example, it's cutting the outside first before it cuts the inside. So if you enable clustering under the sorting tab, you can choose whether you want to do the inside first before you cut the outside, no matter how you select the part regions. So by going into the sorting tab, you can enable perform clustering, and you can choose either you want to go inside out or outside in. So you have the choice. So if you're doing cutting out inside first and then the outside, and you're basically cutting this on a router, or and you're vacuum holding it, so cutting the inside first and the outside would probably make a better sense than cutting the outside first, depending on your application. So you have the option to choose the cut ordering by doing the perform clustering in here. So in this particular example, I'm going to choose inside out, and you'll notice that it automatically cuts the inside first before cutting the outside. So again, this option is available under the sorting tab in 2-axis profiling. This is also one of the enhancements in 2019. The next enhancement I would like to talk about is the ability to use the stock silhouette model for 2-axis facing operation. And to demonstrate this, I'm going to go ahead and take this example in here, and we'll talk about how we can take advantage of the silhouette or the stock extents without having to create any additional stock geometries or boundary sketch regions for the stock geometry. So as you can see in this particular example in here, we have the stock defined. The extents of the stock are much extended past the extents of the part. So in earlier versions, you would have to create a sketch or a region to be able to select that for your defining the part region for facing. With 2019, you can actually directly just go into 2-axis and select facing, and you don't have to pick any machining regions. So when no regions are selected, the system will automatically take the stock extents, the silhouette of the stock, into account for generating toolpath, and it automatically will be prompted with this dialog saying no region selected, and would you like to use a stock silhouette? So as you select yes and generate the toolpath, it automatically accounts for the silhouette of the stock to compute the machining region for the facing operation. So this is a very nice way of being able to program facing operations without having to create any additional sketch geometries in VisualCAM or for SOLIDWORKS. So again, this is available in 2-axis and facing. And if no regions are selected, the stock extents will automatically, the silhouette of the stock would be taken into account for computing the toolpath. So the next thing I would like to talk about here is one of the enhancements that we have for a 2-axis pocketing operation with the 3-axis roughing operation. When using high-speed cut patterns or offset cut patterns, we now have the option to be able to create a tricaudal cut motion from the start point that you've chosen to the first location of cut. So in the case of 2-axis pocketing, I can go into the Start Points tab and use Select Start Points, and I can pick a start point that's already defined on a model. And generating the toolpath will result in a tricaudal motion from the start point that you've chosen to the location of the first cut. Rather than creating a linear motion, as we used to do it in the earlier versions, we now have the tricaudal motion or the high-speed cut pattern motion going from the start point down to the first cut.
Yeah, this type of toolpath obviously gives you constant engagement of the tool on the material as it's cutting, and so you can run this in very high speeds compared to the normal cutting patterns that you would typically use.
So this is available in 2-axis pocketing and 3-axis roughing operations, where operations where you're able to pick a start point for the location of entry. So it is also available in 2-axis and roughing as well, where you have start points. So 2-axis roughing, 2-axis pocketing, and 3-axis horizontal roughing. So the next thing I would like to talk about is the skim clearance enhancement in 2019. And in earlier versions, the skim clearance, when you're programming 2.5-axis operations, used to consider the the height of the sketch geometry or the region, the part region that you are selecting. In 2019, in addition to the sketch, it also looks at takes into account the height of the solid model or the 3D model that you have for accounting for the skim clearance. And I'm going to take an example in here to demonstrate this. First, I would like to show how the skim clearance used to work in the earlier versions and show the difference between the previous version and the 2019 version. So I currently have two operations programmed on this particular example. So we have a profiling and a pocketing operation in here. And I'm going to run a simulation of these two operations. So I'm simulating the profile. So the skim clearance clears the stock material. Now in the case of the pocket operation, the skim clearance did not clear the stock material as it was only accounting for the sketch region height in earlier versions. Now with 2019, I'm just going to go back and regenerate these toolpaths, and you will notice that the skim clearance automatically clears the stock in all these operation types. So let's go back and run a simulation for this again. So you'll now notice that the skim clearance clears the 3D model. Again, folks, if you do have any questions, please feel free to post these questions in the questions panel, and we'll do our best to get those answered for you. Now, there's also been other enhancements to slot machining. So if you have concentric geometries like circles, this would be well handled with the slot machining toolpath in version 2019. And we just talked about the tricaudal motions from the start point to the first cut location. The next enhancements I would like to cover is in the 3-axis horizontal roughing operation, where we've made the clear flats machining algorithm more accurate, where we had noticed some issues due to tolerances when you had fillets or chamfers on the model. Now these have been addressed in version 2019. And to demonstrate this, I will go ahead and bring in an example where you will notice how these fillets and chamfers are handled better in the case of 3-axis horizontal roughing operations when using clear flats in version 2019. So I'm going to again go over an example where the tool generating and simulating a toolpath with an earlier version and compare this with 2019. So here I have two setups in here. The first setup basically shows the toolpath generated using the previous version. We'll run a comparison in here, and you'll notice that due to tolerances, there were some issues in the fillets and chamfers on some of the areas. You can see those areas that are marked in red. Now let's go back and do the same thing in version 2019. And I'm going to run a simulation. And now let's run a comparison, and you'll notice that the issues that you noticed in previous versions, which were due to tolerances, were automatically addressed in 2019. So just bringing in your files that were created in 18 and regenerating them in 2019 will automatically address those, take care of those issues. Again, folks, if you do have any questions, please feel free to post those questions in the questions panel, and we'll be more than happy to answer them for you. So the next enhancements we'll talk about is the cut connections in 3-axis finishing operations like parallel finishing. So we will introduce a automatic arc fitting to these toolpaths to make the cut connections transitions much more smoother in 3-axis parallel finishing, and I'll go through that with an example as well. So the cut connections can be found under the entry and exit tab in 3-axis parallel finishing. So in this particular example, I have a parallel finishing operation programmed, and I'm currently using just a extension without a loop in here. So I'm just doing a linear extension. So I'm going to add loops to it. And then generating the toolpath will result in arcs being fitted to these cut connections. And this is one of the enhancements under the 3-axis methods in version 2019. There's also been other enhancements to 4-axis toolpaths. Now, as far as the 5-axis toolpath method goes, we've introduced what is called the ability to support mutating heads for 5-axis machine tools. Mutating head is one where the primary and the secondary axis are not orthogonal. So as you can see in the machine setup here, there's an option to specify the rotary axis tilt angle for mutating heads, which is available in Pro and Premium configurations of VisualCAM. For folks who are not familiar with mutating heads, here's an example of a mutating head for a head-head configuration machine where you can see the primary and the secondary axis are not orthogonal. So this is one of the type of mutating heads for head-head configuration that we are able to support in version 2019. And this can be done for both indexed 5-axis as well as continuous 5-axis operations. We've also introduced new variables in the post processor that will support for indexed and simultaneous 5-axis operations to be able to output world coordinate system variables and the setup coordinate system variables for 5-axis. This is available in the post processor generator. We'll also like to talk about some of the enhancements to feeds and speeds that have been introduced in version 2019. So I'm going to go over to VisualCAM in here and talk about this. So as you go into your tool definition and you go ahead and choose load from file to set your feeds and speeds, the maximum spindle speed and the maximum cut feed information is now automatically being read from the post processor that you've chosen. So depending on the post processor that you've selected and the high values that you specify for the maximum spindle speed and the maximum cut feed, these values are automatically populated into this feeds and speeds table based on your post processor. So if you change your post processor in here and then go back into the load from file, those feeds and speeds, the maximum values are automatically updated based on what is defined in your post. And you can define the feeds and speeds, the high values in the post, by going into the feed rate section for the feed, high feed value, and the spindle section to set the high value for the spindle RPM, depending on your machine tool. So these values are automatically being read from the post processor when establishing feeds and speeds. I would like to now go over the simulation enhancement that's been introduced in version 2019. So now shank and the holder collisions have been introduced in 2019. So let's go ahead and run a simulation for the profiling operation in here. So we've already simulated the facing, pocketing, and profile, and we'll simulate the profiling operation. Now, as you simulate the operation, you will notice that when a holder or a shank collision is detected, the simulation will pause and will display an error message. And you can step through this by selecting yes, or you can say do not show this again, and selecting yes will run through the simulation and mark these collision areas in red in your cut material simulation for both holder and shank collisions. Now this is also marked in the operation, so you can notice that the operation is flagged dirty. And as you go into your toolpath viewer or toolpath editor, by double clicking on it, you can cycle through the list here and identify the motions that result in collisions, and they're automatically flagged in the toolpath viewer as well. So as you select these cells, you will see the corresponding collisions with the holder and the shank on the toolpath in the viewport. So this is one of the enhancements that's gone into VisualCAM 2019 for SOLIDWORKS. Now regenerating your operation will basically reset the flag, and as you go back and run the simulation again, it'll flag it if there is a collision detect it. So if you change the tool properties to avoid collision, you can regenerate it and then simulate it again. We've also added additional machine tool models for machine tool simulations. The list of machine tool models that you can find has been enhanced with additional machine tool models. And the machine tool simulation is available starting with our expert configuration. So as you go into the machine tool setup tab and select load from file, that currently displays a list of machine tools, and this list has been enhanced with additional machine tool models in version 2019. Now, the next thing I would like to cover here is the enhancements that's been added to the turning module in VisualCAM 2019 for SOLIDWORKS. And to go over this, I'm going to load one of the examples that we had looked at earlier for the Millturn example in here. And we'll talk about the enhancements that's gone into the turn module. So again, folks, if you do have any questions, please feel free to post those questions in the questions panel, and we'll try to get to them. So in turning, what we've introduced is automatically to ignore any of the milling features on a turn when you select a part for turning. So as you establish or select the part for turning, the system will automatically exclude all of the milling features to determine the silhouette for the turn part. So in this particular example here, you'll see that there's these pocket features that are on the part, and these are automatically excluded when you define a part for turning. So this eliminates the need for you to go back and recreate the model or suppress the mill features that you had already modeled on it, or having to create an additional sketch. So by selecting the entire part, the milling features, other features that are automatically being excluded in defining the part, so which makes your programming workflow a lot easier and eliminates the need for you to having to create these additional steps in turning. So as you take a look at the part definition here, you will now notice that the milling features are automatically excluded when defining the part for turning. So this is one of the enhancements that's been gone into the turn module. In addition to this, the feeds and speeds enhancements we talked about, loading from file, will also applicable to the turning module. So whatever the high values that you have set for your spindle RPM and the feed rates can also be loaded into the feeds and speeds computation in turning as well. And as well as when you do post-processing, if you have tool number conflicts in turning, these would also be, the user will be notified about the tool number conflict in turning. So again, folks, if you do have any questions at this point of time, I'll be more than happy to take those questions and answer them for you.
There's a couple of questions here. One of the questions relates to pricing, and I can take that. Let me address both. There were both questions related to price. One is, are there any price changes for our with the new configuration changes? The exciting part for customers, I believe, is that there are no price changes from the 2018. So in fact, what you're getting is you're getting what used to cost over $1,000 for the turn module now is part of the CAM mill module, starting from the standard configuration, free of cost, basically. You can think of it as free of cost. So for $1,500, you get a complete CAD/CAM system, but that includes both milling and turning modules. So that's no price changes for the 2019 product. And then there was another question about the Millturn pricing. Millturn will be a separate module. Yes, it'll be an add-on module that'll be priced separately. So that we're hoping to release it in the next few months, and we will be announcing the pricing at that point. There's one other question today. I don't know whether you can show this really quickly. Does this work? Does SOLIDWORKS, VisualCAM for SOLIDWORKS work in assemblies? The answer is yes. We released that in 2018, the ability to work in assemblies. I'm not sure if you can show that real quickly.
Sure, I can try to bring in an example here to go over that, how VisualCAM for SOLIDWORKS can run in assemblies. So Folks, give me just a moment here while I try to look up an example where we can run VisualCAM for SOLIDWORKS in an assembly.
Yeah, this functionality was released in our 2018. It's not new, so we released it last year, so it's been out in the field for about a year now. So you are able to load parts inside an assembly and just select parts for machining.
Yep. So the mill module can be run within an assembly, and you can basically select parts. So as you go into the machining browser, you'll now have the option to select the parts that you'd like to use for machining, and you can select the part that you'd like to select in here for machining in VisualCAM for SOLIDWORKS to program it. So it works in assemblies as well as in a part document.
Okay, can you show the toolpaths? Just click through the toolpaths and we can see the toolpaths.
Sure, absolutely. Just give me a moment here.
Okay. All right, if looks like we don't have any more questions at this point. Is there any? We'll hang on for a couple of minutes here to entertain any of the other questions you might have. Looks like Uday's having some issues with the graphics display freezing. Okay, there you go. He's got that going. So that's, yeah, go ahead, Uday.
So we got the part displayed, so you can actually select the part. You can select one or more parts from an assembly for machining. So here you have the machine environment built in. You have your fixtures, and this is the part we're looking to machine. So the stock will be defined based on the part that you define, and then you can program your machining operations just like as you do in just a part environment. So we have a facing operation and a pocketing operation programmed in here, and I'm going to run a simulation for the two operations.
Okay. All right, Uday. Thank you very much, Uday. And one other item that I want to mention, we are in our planning phases for our next release, for the 2020 release. And so if anyone has any enhancements that you would like to see in the product, this is the time to get it into us. Send us an email to support@mecsoft.com. And we will try to prioritize that and add it to our 2020 release. So looks like that's all the questions we have today. Thank you for a very good demo. And we are always here for you to entertain any sales-related questions or technical questions. You can send email to sales@mecsoft.com or support@mecsoft.com. And you can also reach us by phone or Skype, or even our website. Go to our website. There's some forms you can fill out if you have any questions. If you're outside the country, we'll be more than happy to answer that. So again, thank you for your time. And we will be sending out the recording of the webinar to all the registrants. And so thank you again and take care. Bye-bye.
Thank you.